Okay, in this section we're going to look at factoring. And if factoring is not something that you're really comfortable with, don't worry about it. I'll talk a little bit about some tips and tricks that you can use during the test to maybe work backwards. But if you are familiar with factoring, we're just going to go over a little review of what we got going on here. So the first thing that you want to do when you're factoring any expression is find the greatest common factor of all of the terms. So when you're finding the greatest common factor, the first thing you want to do is find the greatest common factor of the coefficients, the numerical part, the number part of each term. Then you want to locate what are the common variables in each of the terms, and then you want to find the smallest exponent of those variables, and that's going to help you determine your greatest common factor of your three terms. So let's look at some monomials as examples. Let's say I have the term 15x squared y and 20xy. So first I'm going to look at the coefficients, 15 and 20, and the greatest common factor of 15 and 20 is 5. And then I look at the variables. So I see that both terms have an x term in it, or an x variable in it, but the smallest exponent that we see there is not x squared, but x to the first. So x is going to be one of my greatest common factors. Both terms have a y, so 5xy will be my greatest common factor. Let's look at another example where we have three terms. 9m cubed n to the fourth, 12m squared, and 18mn. So 9, 12, and 18, the greatest common factor of those is 3. I notice every term has an m, but m to the first is the smallest exponent, and not every term has an n, so 3m is the greatest common factor in this example. Here's some example with trinomials. 3x squared plus 6x minus 9. Not every term has an x, so the greatest common factor here is going to be the greatest common factor of the coefficients, which is 3. And if I factor out the 3, then I'll have x squared plus 2x minus 3. So if I multiplied this back together by distributing, I'd end up with what I started with. Let's look at another example. 6x cubed, 18x squared minus 108x. Now, the greatest common factor of 6, 18, and 108 is 6. And I see that every term has an x. The smallest exponent is 1. So I can factor out a 6x. And then I say, well, 6x times what was 6x cubed? X squared. 6x times what would give me 18x squared? 3x. 6x times what would give me negative 108? And that is negative 17. 19. JK, negative 19. 18. Just to see if you're paying attention. Miss Horton is. She's got me covered. 18 there. Okay, one last example. 24x squared y plus 28xy squared minus 20xy squared. Greatest common factor between 24, 28, and 20 is a 4. Every term has an x. The smallest exponent is 1, so we pull out x to the 1. Every term has a y. Smallest exponent is 1, so we pull out a y to the 1. So 4xy times what would give me 24x squared y? That would be 6x. We already pulled out the y, so there's no y left there. 28xy squared, 4 times 7 is 28. We already pulled out an x, but we need a y to get the y squared if we multiplied it back together. And then 20xy squared would be 5. We pulled out the x, 5y. So that's how we can pull out the greatest common factor there. Now, I would probably go a step further and simplify this because these are like terms 7y minus 5y, and simplify that to 2y. Okay, let's talk about factoring trinomials into binomials. First thing you want to do is check to see if there's a greatest common factor. Then you want to write your parentheses, figure out what your first term is, figure out what your signs should be, and then figure out what your last term should be in your parentheses. So let me give you an example of how this should work. Here's an example of a trinomial where all your signs are positive. My first term is x squared, and then we have plus 8x plus 12. So I notice that there is no greatest common factor because not everything has an x, and the 1x squared has a coefficient of 1. So the next thing I do is write my parentheses. So I'm going to factor this into a product of binomials. And I notice that since both of the signs are positive, that means that this has to be a sum in both of these. The first term in each has to be x. That's the only way I can multiply this together and get x squared, 1x squared. Now we're going to try to fill in the last term here. That has to be an x. We want numbers that multiply to 12. That's going to go here and here, multiply to 12 and add up to 8. So two numbers that multiply to 12 and add up to 8 are 6 and 2. Now think about it. If I used FOIL here, firsts, x squared, plus my outers, x times 2 is 2x, plus my inners, 6 times x is 6x, plus my last, 6 times 2 is 12. If I simplify that, I get back what I started with, x squared plus 8x plus 12. Alright, next example, 3x squared plus 18x plus 15. Pull out the greatest common factor first, which is a 3. And so we have x squared plus 6x plus 5. Then again, I can do my parentheses. The first term has to be an x. Both of these are positive, so that means I'm adding here. And then we want factors of 5 that add up to 6. Well, how about 1 and 5? And that's how we factor that. Now, just a quick tip here. If you have an expression like this that you have to factor and you're not sure how to factor it, look at your answer choices and work backwards. See them all, multiply them back together using our FOIL technique, and see which one is equal to the original expression. Otherwise, I'm just going to go through a couple more examples of factoring here. Let's say we have mixed signs, so we have a negative and a positive here. I'm going to start by putting in my parentheses. My first terms have to be x to multiply to x squared. And then I want factors of 12 that add up to negative 7. Now because this is a positive 12 here, the only way I can get factors of positive 12 that add up to negative 7 is if both factors are negative. So thinking about 12, we have 1 and 12, 6 and 2, or 3 and 4. 3 and 4 add up to 7. And so to add up to negative 7, we want negative 3 and negative 4. So my middle terms here would be x squared minus 3x minus 4x, and then negative 3 times negative 4 is positive 12. Next example, 2x squared plus 4x minus 30. First we're going to pull out the greatest common factor, which is a 2. So we have 2 times x squared plus 2x minus 15. Now notice that my sign here is negative, but my middle term here is positive. I know my factors of 15, one has to be positive, one has to be negative. And then I have an x and an x, so I want factors of 15 that add up to positive 2. So how about positive 5 and negative 3? So positive 5 times negative 3 is negative 15, but positive 5 minus 3 adds up to positive 2. One last one that's a little bit trickier here, and here sometimes you just want to play around. But I notice that this is a positive and this is a negative, so both of my terms here must be negative. And I'm just going to play around with factors of 8x squared. So I'm going to try x times 8x. And if that's the case, I want factors of 6 here that when I multiply them together, and I multiply, how am I going to put this? If I multiply these two pieces together, they need to add up to negative 19. So the way that this one is going to work is going to be x minus 2 times 8x minus 3. So if we think about this, negative 2 times negative 3 is positive 6. And then negative 2 times 8x is negative 16x. X times negative 3 is negative 3x. That adds together to give me my middle term of negative 19. Again, work backwards from the answer choices if you need to, if you're not sure how to factor something complex, if you run into this situation. Okay, last thing with factoring techniques is this special pattern of a squared minus b squared. A squared minus b squared always factors to a minus b times a plus b. And that's a really handy formula to just know and memorize. It's going to pop up year after year after year after year in your math classes. So let's look at a couple examples. X squared minus 25. Now 25 is a perfect square, so I could write that as x squared minus 5 squared. So this is like my a, this is like my b. So that factors to x minus 5 times x plus 5. Here we have 4x squared minus 36. 4 is a perfect square, 36 is a perfect square. So I could write that as 2x squared minus 6 squared. So 2x is like my a, 6 is like my b, so that's going to be 2x minus 6 times 2x plus 6. Here we have 9x squared minus 49y to the 4th. Well, we can still use our pattern here. We're going to make that 3x quantity squared minus 7y squared quantity squared. How come y squared? Remember when you raise a power to a power, you multiply the exponents? That would give me my y to the 4th. So factored, this would be 3x minus 7y squared times 3x plus 7y squared. That goes on the inside there. One last one. What if you have something like this, 32x squared minus 2? It doesn't appear to be a special pattern because 32 is not a perfect square. But remember to check to see if there's a greatest common factor. Greatest common factor between these is 2. If I pull out the 2, now I have 16x squared minus 1. 16 is a perfect square, 1 is a perfect square, so this could be 2 times 4x squared minus 1 squared. And now you see 4x would be your A, 1 would be your B, so this would be 2 times 4x minus 1 times 4x plus 1. Okay? Now, how are we going to use these factoring techniques? They're a great way to help us solve quadratic equations. So sometimes what you'll be asked to do is factor the trinomial or factor the quadratic so that you can find the zeros or the values of x that make it equal to 0. So our steps here are going to be to transform something like ax squared plus bx plus c equal to 0. So whatever equation we have, the first thing we want to do is set the whole expression equal to 0. So move your terms around. Then we're going to factor the expression, set each factor equal to 0, and then solve the two separate equations. So let's take a look. We have x squared plus x equals 12. First thing I want to do is make sure that this is equal to 0, so I'm going to subtract 12 from both sides of the equation. So I have x squared plus x minus 12 equals 0. Write my parentheses. I know this has to be an x and that has to be an x to multiply to x squared. I want factors of negative 12 that add up to positive 1. So we have positive 4 and negative 3. Now I'm going to set each factor equal to 0. So x plus 4 equals 0. Subtract 4 from both sides. We get x equals negative 4. X minus 3 equals 0. Add 3 to both sides. And we get x equals positive 3. One last example here. 5x squared plus 5x equals 30. So remember, get this equation set equal to 0 first. So we'll subtract 30 from both sides of the equation. Then I notice that they all have a greatest common factor of 5. So we'll pull out that factor. So we have x squared plus x minus 6 equals 0. We'll write in our parentheses so we can factor the expression. We're going to have an x here and an x here. And now let factors of 6 that add up to positive 1. So plus 3 and minus 2. And again, right here, all we need to do is set each factor equal to 0. We don't really need to worry about the coefficient. So either x plus 3 equals 0, subtract 3 from both sides and x equals negative 3, or x minus 2 equals 0, add 2 to both sides, and x equals positive 2. That's how you can use your factoring techniques to help you solve your quadratic equations.